Hello boys and girls, welcome to lesson 1-2, Words and Expressions. Today we will learn to translate verbal phrases into numerical expressions. What we're saying is we're going to listen to words in real world context and see what the operation will be. For example, when they say find the sum, we know that we need to add. When they say find the difference, we know we need to subtract. Use the order of operations to evaluate each expression. Real world link. This is quite interesting actually. Inventions. The first consumer digital camera was introduced in 1990. So the first digital camera for widespread use was in 1990. The portable music digital player was introduced in 2001, so what we know to be the MP3. And a video sharing website began in 2005, much like this one. You can use numbers and operations to find how many years apart these events are. So if we wanted to find the difference, we would subtract these values, the greater one from the lesser one. So here we can see if we were to subtract these two, we would get 15. And if we were to subtract or find the difference between these two, we'd find 11, and between these two, 4. So finding the difference between these would help us identify how far apart they were. And the difference is subtraction. Let's look at our key concept. Translate verbal phrases into expressions. To find the number of years between the introduction of digital cameras and the portable music digital player, you can use the numerical expression 2001 minus 1990. Numerical expressions contain a combination of numbers and operations such as addition, subtraction, multiplication, and division. So let's get familiar with these. When we find addition, we say the sum. For subtraction, we say find the difference. For multiplication, we say find the product. And for division, we say find the quotient. That's a cue. Example 1. Write a numerical expression for each verbal phrase. The total amount of money if you have $9 and $12. So what are some keywords we need to outline here? They're asking for the total amount, and they're saying $9, which they give you the value, and $12, and $12. So the phrase is the sum of 9 and 12, if we wanted to write it in words. And the numerical expression is 9 plus 12. Let's see. The age difference, look at that, between 15 years old and 10 years old. The difference, and then they tell us 15 years old, right here, and 10 years old. So when we're looking for the difference of 15 and 10, we take the larger number and we subtract the smaller number. The numerical expression would be 15 minus 10. This seems easy at first, I understand, but a lot of times when we're reading more difficult word problems, we really have to make sure we pay attention to the words carefully so that we know what operation to use. So if you think you got it, go ahead and try numbers 1A to 1D. Pause the video now. Okay, 1A. The cost of 10 yo-yos if each costs $3. So 10 yo-yos and each of them cost $10. Sorry, $3. So again, I'll outline the 10 yo-yos and each costs $3. And we want to know the total cost, correct? So 1A looks like this. We have 10 yo-yos and each of them is $3. Notice I'm looking for the product. So it would be $30. No, they're not telling us to evaluate. I believe they're just asking us to write it in numerical expression, right? So we're looking for the product at this point. 1b, the number of students in each group if 15 students are divided into equal groups. So they want us to divide 15 students are divided into 5 equal groups. So 15 divided into 5. So we take our 15 and we divide it by 5. And we know that 15 divided by 5 is 3. So therefore there would be groups of 3 students. We were looking for the quotient, for 1b, quotient. 1c, the number of students on 3 buses if each bus holds 22 students. The number of students on 3 buses if each bus holds 22 students, right? So we were looking for the product. They're giving us, they're telling us that each bus, out of the 3 buses, each one has 22. So it would be 3 times 22. And 1d, the amount of money Nina earned if she mowed the lawn for $15 and walked the dog for $4. So it sounds like she only mowed the lawn one time and she walked the dog one time. So these terms are only expressed once. So we have $15 and we're looking for the total amount of money. So she walked the dog, earned $15, and then, mowed the lawn, earned $15, and then she walked the dog and earned $4. So we have our $19. Okay, again, now we were not asked to actually evaluate and solve. They really just wanted us to see if we could write the proper calculations or the proper numerical expressions with the operations, the correct operation, multiplication, division, addition, and so on. So now that we worked with words and expression, let's work with order of operations. In order of operation, we have these acronyms that we can use, and they differ from the way we write it out in Canada and the way we write it out in the US. But they follow the same rules. For example, step 1, simplify the expressions inside grouping symbols, which are talking about parentheses or brackets. Step 2, multiply and or divide in order from left to right. So we can either multiply or divide depending on which one comes first. But we cannot do it before we do the brackets. And step 3, add or subtract in order from left to right, whichever one comes first. So if we're doing that, we can follow the rules of PEMDAS. And what is PEMDAS? Well, for PEMDAS, we have parentheses, exponents, multiplication, division, addition, subtraction. Multiplication and division can be interchanged depending on which one comes first. It could be division first. We do it from left to right. In addition and subtraction, we can do addition or subtraction first from left to right, whichever one comes first. So you might have subtraction first, but these two can be interchangeable and these two can be interchangeable. The first one is parentheses, which we call brackets in Canada, or usually we refer to that in other math classes in Canada. So in Canada, we normally call it BEDMAS for the order of operation. It's the same thing. We have brackets, which is parentheses, exponents, division or multiplication, addition or subtraction. So again, these two could be, division and multiplication can be interchangeable, and addition and subtraction can be interchangeable depending on which one comes first from left to right as you're reading the expression. So let's take a look here. To evaluate an expression, you find its numerical value. If an expression has more than one operation, use the order of operations. These ones. It's the same one. Same thing. The order of operations are the rules to follow when evaluating an expression with more than one operation. These rules ensure that numerical expressions have only one value. Here you can see many examples of how order of operation is implemented from A to E. So you can see here that in one operation, in the first expression, we have two different computation. Okay, we have two different operations. So we have 20 minus 3 times 5. We must follow order of operation and do the multiplication first. 3 times 5 is 15. And then we get 20 minus 3. If we were to not follow order of operation, we would get something, a completely different answer than 5. It would not be 5. Let's say I would just do this from left to right, and I would interchange subtraction and multiplication, which you're not supposed to do. And it takes 20 minus 3 is 17, right? And then 17 times 5 would give me 85. These two are completely different. You see that? So it's really important for us to follow order of operation. 30 divided by 5 times 3. These two can be interchangeable, but we must do it from left to right. If we had multiplication first here and division here, we would do the multiplication first. But we have division, so we will do the division first, and we have 30 divided by 5, okay, which is 6. And then we'll do the multiplication second. 6 times 3 is 18. Now we have one operation, two operations, three operations, four operations, and one of them is in parentheses. Notice that I counted this one as 4 because the 4 will be multiplied into the difference that we find in here. Parentheses comes first, don't forget, or brackets you could say. PEM DAS, just as a reminder. So we have parentheses first. And we find the number in the parentheses. 10 minus 7 is 3. There it is. Now we must do multiplication or division. And here's our first multiplication, which is 12. 4 times 3 is 12. I would have done this one at the same time. It's another multiplication. 2 times 3 is 6. And then finally you find the sum of the two, and you get 18. For number 5, we have something called nested parentheses. A nested parentheses is when you see we have a parentheses here that actually closes all the way here, right? But inside of that we have another one, okay? We must do the nested parentheses first, the one inside. Nested, like a nest. It's nested inside there. So we do that one. You see that we get 12. Now I can do the big parentheses, and then inside the parentheses I also follow order of operation. I have subtraction and division. You know we must do division first. So we get our 3. And then we do our subtraction inside the parentheses still. Even though we have multiplication here, we must do the operation inside the parentheses. And then we get 40. And now we have for E, 60 minus 15 over 2 plus 7. You're probably wondering what we have to do first here because we have division. What you can do is you could write it, rewrite the expression so that it's not looking like a ratio or a fraction. So we write it the long way. But we know that these have to be done first in order for us to be able to solve the fraction. So because these have to be done first, we must write them in parentheses. So when we have that, we write 16 minus 50 is 45, and 2 plus 7 is 9, and then we divide and we get our 5. And here comes the fun part. If you think you got it, please go ahead, pause the video, and try these 4 on your own. Pause now. Okay, let's try 2a. For 2a, we only have subtraction and addition. I can do them interchangeably, but I will do them from left to right as the rules demand. 6 minus 3 is 3. Plus 5 is 8. Let's try 2b. We have division and multiplication. Again, these two can be interchangeable, and so we do them from left to right. And we have 24 divided by 3 is 8. Now bring down my 9 that I have here, right? And 8 times 9 is 72. Let's try 2C. We have nested parentheses, as you can see. It's starting to get a little confusing, but make sure that you outline the first parentheses and the closing parentheses. Work with all of this first in here, and then leave this to the last part because it's outside the parentheses. Now that we are in here, we know that we have nested parentheses. So I'm going to go ahead and use that as my first line. I write my 2. Okay, I'm going to solve inside the nested parentheses first. 10 minus 3 is 7. Plus, I can go ahead now and solve one multiplication because I solved the nested parentheses first. And 6 times 5 is 30. Now, I just simply have 7 plus 30. This is not multiplication because the number's not next to it. There is an addition sign. Okay, if it were 7 parentheses 30, it would be multiplication. But remember, there is an operation right in between the two terms. So it's 7 plus 30 equals 37. Put that back in the parentheses, and I have it times 2. And 37 times 2 is 74. And finally, 2D. Now for 2D, we can write it linear. We can write it all in one line like this, where we take our top part of our fraction, our numerator, and we write in a parentheses, and then we divide by the denominator, the expression we have as the denominator. So 25 minus 22. I typically don't do it like this. What I do is I solve the expression as I see it. I will solve for my numerator first and my denominator. So what I would do is I would just simply write my fraction again. I solve the top. 19 minus 7 is 12. And on the bottom, 25 minus 22 is 3. And now we just have an improper fraction, or we could say a division, where we take the top and divide it by the bottom. 12 divided by 3 is 4. And for example 3, we have a word problem. Let's zoom in and read it. A cell phone company charges $20 per month and 15 cents for each call made or received. So it looks like no matter what, just for having the line, you have to pay $20. And every time you receive or make a call, you have to pay an additional 15 cents. So if you have the phone and you only make one call or receive only one call, you're going to pay $20 and 15 cents. If you make 2 calls, you're going to pay $20 and 30 cents. Does that make sense? Write and evaluate an expression to find the cost for 40 calls. So 15 cents times 40, right? Then make a table showing the cost for 40, 50, 60, and 70 calls. So they want to know, then make a table showing the cost. So don't forget that we have to pay for the calls, and we also have to add 20 to it. So for example, for 40 calls, it would be 15 cents times 40, right? Plus 20. It would look like this. In words, $20 per month and 15 cents for each call or received. The expression 20 will be added to the product of 0.15, 15 cents, times 40. And we solve for the multiplication first, then we add our 20. And you can see that 40 calls would cost a total of $26. $6 for the calls, the incoming and outgoing calls, and $20 for just the line. So 40 calls would cost $26. Make a table showing the cost for 40, 50, 60, and 70 calls. And here we have it. 40, 50, 60, 70 calls. We still add 20 to all of them. We still are multiplying it by 15, so these are constant. And the only variable is the number of calls outgoing and coming in. Variable meaning because it varies, it changes. So we first find the product in each line, and then to each line we add the 20. And here's our total costs. As the number of calls increases by 10, the cost increases by $1.15. $1.50. Makes sense, because 15 cents times 10 is $1.50. Okay, if you think you got it, remember to pause and read this and try to complete it on your own. Pause now. Okay, I hope you paused the video. Let's try it. The same phone company offers another plan where they charge $15 per month. So instead of 20, they're going to charge 15 and 25 cents for each call made or received. So 25 cents for each call made or received. So let's say if you receive or make 4 calls, that's $1. So for every 4 calls, you're going to have to pay $1. There's 4 quarters in $1. Write an evaluating expression to find the cost for 40 calls during 1 month. Then make a table showing the cost for 40, 50, 60, 70. So let's just evaluate this quickly. And I'm only going to do this to make sure that you have your answer correct. You know that you are supposed to make a table like this one, okay? And your expressions are going to change slightly. They're going to change. Let me zoom in. Okay. The number of calls have been the same, right? But over here, we have to change our expression. For example, instead of 20, we're going to write, in each one of these, we're going to write 15 because 15 is how much we're going to pay. So let's change those to $15 per month, right? $15 per month, $15 per month, $15 per month. And now it's no longer 15 cents per call, it's 25 cents. So let's erase those as well. And there we have it. And these are not correct, so I'm going to go right ahead and erase those as well. Okay, just give me 1 sec. Those are erased. And now we can solve. Now, for every 4 calls, it's going to be $1. So here we have $10 because it's 40, not 4, right? Makes sense? So here we have $10 plus 15 is 25. So $25. Oh, that's looking cheaper already than the previous number that we had, because the previous plan, if I recall correctly, was $26. So now we only have $25. We saved $1. Now, what does that mean? It means how much is it going to go up by every time I have 10? Every 10 that I have, it's going to be an additional $4. An additional $4. The reason I say that is because, remember, every 4 is $1. Every 4. Sorry, I did some bad calculation there. Every 4 is $1. Every 8 will be $2. Plus 2 more is 50 cents. So every 10 more will be $2.50. And it makes sense because 0.25 times 10 is 2.5, like this. Let me just write that down here. We have 0.25 times 10. And the reason I'm doing times 10 is because it's always changing by 10 more. And so I just want to see what the difference will be. This 10 right here is going to move the decimal over one place to $2.50. See? 2.5, right? It's 0.25 and it moves the decimal place over 1 because it's multiplied times 10. It becomes 2.5 or $2.50. So we simply just have to add $2.50 to that. So it becomes $27.50. Now it becomes $30. And then it becomes $32. Oops. $32.50. Okay, if that doesn't make sense to you, please go ahead and actually find the product and add 15. Find the product, add 15. Find the product, add 15. Multiply, add 15. Multiply, add 15. Okay, everybody. Here's a guided practice. Please go ahead, take a look at the guided practice. Make sure that you feel comfortable with the word expressions, the expressions that we must evaluate and solve, and the word problem. And if you're not comfortable, please go back to these examples in the video, example 1, example 2, example 3, to make sure that you're more familiar with it. This is how we will start class next class. See you then.